Good day, students. Welcome to our lesson for today. Last week, we had discussed the basic integration formula, including the definite and indefinite integrals. For our session for this week, we're going to have integration by substitution, applying the general power formula. For example, we have number 1, the integral of 24x squared times 8x cubed plus 5 dx. So the first thing that we have to do is to represent u. So let u be 8x cubed plus 5. Then get the derivative, or du is 24x squared dx. Okay? So as you can see here, we have our u and then we have our du. Our du is 24x squared dx, and we have here 24x squared dx. Okay, so let us express our given in this form. The integral of 8x cubed plus 5 times 24x squared dx. So as you can see, this is in the form of u du. Okay? So the integral of u du. So let us integrate this. The integral of u du is equal to u squared over 2 plus c. Remember, applying the general power formula or the basic integration formula. And then substitute u. That's why this process is called integration by substitution, because we are going to substitute the value of u, which is in this case 8x cubed plus 5. So we can express our answer as 8x cubed plus 5 squared all over 2 plus c. Or we can express this in terms of 1/2 8x cubed plus 5 squared plus c. Okay? I hope you understand the process. This is very easy to follow. Let us now proceed to our second example. Example number 2. The integral of 6x cubed times 3x to the 4th minus 7 dx. So the first thing to do is to represent u. Let u be equal to 3x to the 4th minus 7. Then get the du. Du is 12x cubed dx. Okay, now, so our given is 6x cubed 3x to the 4th minus 7 dx. We have here 6x cubed, but in our du we have 12x cubed dx. Again, from our given we have 6x cubed dx, then in our du we have 12x cubed dx. So what are we going to do here? What are we going to do to get 6x cubed dx also from this? Correct, we are going to divide both sides of this equation by 2, or multiply both sides of the equation by 1/2. So 1/2 du is equal to 6x cubed dx. Okay, because we multiply both sides by 1/2. 1/2 times du is 1/2 du. 1/2 times 12x cubed dx is equal to 6x cubed dx. Okay? And then, let us see our given. So our given is in the form of the integral of u times 1/2 du. So as you can see, we have the u here. U is 3x to the 4th minus 7, and our 1/2 du is 6x cubed dx. Okay? And then let us put this coefficient outside the integral symbol, or the symbol of integration. So this will become 1/2 the integral of u du. So this u du is already integrable. So let us integrate it. This will become 1/2 times u squared over 2 plus c. So as you can see here, we have this 1/2. So times our u du becomes u square over 2. And then do not forget our constant of integration, which is c. And then lastly, substitute the value of u. So we're going to have 1/4 times 3x to the 4th minus 7 squared plus c. So as you can see, so 2 times 2 is 4. That's why it became 1/4. Okay. Or if you want to express your answer like this, that's okay. 3x to the 4th minus 7 squared all over 4. Example number 3. The integral of 30x 5x squared plus 6 dx. So let u be equal to 5x squared plus 6. Get du. Du is 10x dx. So it's just getting the derivative, okay? And then we are going to multiply both sides of the equation or both sides of du by 3 kasi we have 30x dx. So we only have 10x dx here. That's why, okay? That's why it will become 3 du equals 30x dx. So now it's the same. From the previous example, we divided by 1/2, but this time we multiplied by 3. Our given is in the form of integral of u times 3 du. So put the coefficient outside the symbol of integration. This will become 3 integral of u du. Then u du is integrable, so the integral of u du will become u square over 2. So this will become 3 times u square over 2 plus c. And then substitute the value of u, which is 5x squared plus 6. So our answer will become 3 over 2 times 5x squared plus 6 squared plus c. Or 3 times 5x squared plus 6 raised to 2 all over 2 plus c. So it is very important for us to know how to express our answers in different forms. Number 4. Let's have the integral of 2x minus 1 raised to 3 dx. So actually we can expand this because this is just cube. So cube of a binomial. If you expand this will become the integral of 8x cubed minus 2x squared plus 6x minus 1 dx. So you can actually write the integration symbol on each term. So in this case, the terms are inside the parentheses, but if you are going to distribute the symbol of integration in each terms, you will also distribute dx. So as you can see, all the terms have the symbol of integration and the dx. So we have now the integral of 8x cubed dx minus the integral of 2x squared dx plus the integral of 6x dx plus the integral of dx. So apply the general integration formula. This will become 8x to the 4 over 4 minus 12x cubed over 3 plus 6x squared over 2 minus x plus c. So do not forget the constant of integration. So we can simplify this because 8 divided by 4 is 2, 12 divided by 3 is 4, 6 divided by 2 is 3. So this will become 2x to the 4th minus 4x cubed plus 3x squared minus x plus c. So this is our answer. Now, so same given, but now we are going to use another method. Okay. So let's have the integral of 2x minus 1 raised to 3 dx. So let us use here the integration by substitution. So let u be 2x minus 1. So our du is 2 dx. So we don't have a coefficient here, we only have dx. So to get dx, let us divide both sides by 2 or multiply both sides by 1 half. So we're going to have 1 half du equals dx. So we have now dx and dx. And then let us express this in the form of u cubed times 1 half du. Because obviously this is our u cubed and then this is our dx is 1 half du. So put the coefficient outside the integration symbol. So now we have u cubed du or 1 half the integral of u cubed du. So u cubed du is integrable. So let us integrate it. It will become 1 half times u to the 4 over 4 plus c. So substitute the value of u. So this will now become 1 over 8 times 2x minus 1 raised to 4 plus c. Okay. If you expanded it and divide the terms by 8, so we're going to have the same answer from the previous example. In this case, we use integration by substitution. So why do we need to learn this method? Because you may say we can just expand it. For example, this case, 2x minus 1 cube. We can easily expand that because it is just a cube of a binomial. What if the exponent here is 10 or 20? So if it is raised in a higher power, it's very hard to expand it, right? You're going to have an algebra expression with a lot of terms. Your entire bond paper might not be enough for those terms. Okay, so that's why we have this method. So ito, we can actually express our answer here as 2x minus 1 raised to 4 all over 8 plus c. Okay, number 5. So this is what I'm talking about. For example, the integral of 2x minus 1 raised to 12 dx. So if you're going to expand this raised to 12, so you're going to have an algebraic expression with a lot of terms. That's why we will use integration by substitution. Let u equals 2x minus 1, du is 2 dx. We only have dx here, so you know what to do. Multiply both sides by 1 half, so this will become 1 half du equals dx. And then write our given in the form of equals integral of u raised to 12 times 1 half du. So obviously this is our u raised to 12, this dx is our 1 half du. Okay? And then before you substitute, integrate first. Or before you integrate, if there's a coefficient, put it outside the integration symbol. So this will become 1 half the integral of u to the 12 du. So u to the 12 du is integrable. So this will become 1 half times u to the 13 over 13 plus c. And then substitute the value of u. So this will become 1 over 26 times 2x minus 1 raised to 13 plus c. Example number 6. Okay, so the integral of x times 7 minus 5x squared raised to 4 dx. So let u be 7 minus 5x squared. Then du equals negative 10x dx. So we only have x dx here. So what are we going to do now? Multiply both sides of the equation by -1/10. Okay. So this will become -1/10 du equals x dx. It's because we have x dx here. So our given is actually in the form of u to the 4 times -1/10 du. Let's write it as -1/10, the integral of u to the 4 du. This u to the 4 du is integrable, so this will become -1/10 times u to the 5th over 5 plus c. Then substitute -1/50 times 7 minus 5x squared raised to 5 plus c. So this is our final answer. So that's why it is called integration by substitution, because we are making substitutions here in order for us to solve or to find the integral. Okay, so look at this example. Number 7. The integral of 2x cubed plus 1 square times x to the 5th dx. Okay. So algebraically, you can just expand this because it is only raised to 2, then multiply x to the 5th. But now, in this case, let us apply integration by substitution. So let u be 2x cubed plus 1, and du is equal to 6x squared dx. So we divide both sides by the equation by 6, or multiply both sides of the equation by 1/6. So this will become 1/6 du equals x squared dx. But look, we have x to the 5th dx here, but we only have x squared dx. So what are we going to do? Actually, there is an x squared here hidden. Let us show the x squared. So our given can be written as the integral of 2x cubed plus 1 square times x squared times x cubed dx. So as you can see, there is an x squared dx now. Okay? We have now our u, our 1/6 du. So there is x cubed. We're going to get x cubed. Okay, so in this case, I'll look at this. So we're going to get x cubed from our u. How are we going to do that? Look at this, u equals 2x cubed plus 1. So you can express this as u equals 2x cubed plus 1, right? And then how are we going to get x cubed? So by transposition, this will be 2x cubed equals u minus 1. Then divide both sides of the equation by 2. So that will become x cubed equals u minus 1 all over 2. Okay? And then let us substitute. We have our u, we have our 1/6 du, and now we also have our u minus 1 all over 2 from our example. So substitute. 2x cubed plus 1 square became u square. Our x cubed became u minus 1 all over 2. Our x squared dx became 1/6 du. So actually we have 1/2 here and then 1/6. 1/2 times 1/6 is 1/12. Let us put 1/12 outside the integration symbol. So this will become 1/12 times the integral of u cubed minus u squared du. So this is already integrable. If we will be integrating this, we're going to have 1/12 times u to the 4/4 minus u cubed over 3 plus c. And then substitute the value of u. Change u to 2x cubed plus 1. So our answer will become 1/12 times 2x cubed plus 1 raised to 4 all over 4 minus 2x cubed plus 1 raised to 3 all over 3 plus c. So this is our answer. Okay? So, class, in our lessons, this is my advice or tip to you. So, after listening to an example, try to solve it also. After that, proceed to number 2. After listening to number 2 and after solving number 2, proceed to number 3. After listening and solving number 3, proceed to number 4 and do it for the next items, okay? So that you will be more prepared in answering the exercises and our worksheet. Okay? So now I will be leaving you with some exercises. Evaluate each indefinite integral, write complete and necessary solutions. This will also be a part of your output this week. Number 1, the integral of negative 15x to the 4 times negative 3x to the 5th minus 1 raised to 5 dx. Our u here is negative 3x to the 5th minus 1. So this is our answer. So I will be giving you the answer. What you have to do now is to write the complete solution, okay? Number 2, the integral of negative 8x cubed over negative 2x to the 4 plus 5 raised to 5 dx. Our u here will be negative 2x to the 4 plus 5. So in this case, I advise you to write this term in the numerator. So the 5 here will be negative 5. And then for number 3, the integral of 36x cubed times 3x to the 4 plus 3 raised to 5 dx. U is 3x to the 4 plus 3. This is our answer. Number 4. So in this time, you're going to apply what you have learned from the what do you call this? Derivative of trigonometric function. So now we have the integral of 4 secant 4x times tangent 4x times secant raised to 4 4x dx. Our u is secant 4x. So this will be our answer. Number 5, negative 9x squared times negative 3x cubed plus 1 raised to 3 dx. I will not be giving you the u anymore, okay? But still, I'm going to give you the answer. So here's what you must do, okay? So try to answer this and then post the video after answering, and post the video and check if your answer is correct. If your answer is not correct, then try to solve it again. So number 6, the integral of negative 12x squared times negative 4x cubed plus 2 raised to negative 3 dx. So number 7, we have the integral of 1 plus e to the x raised to 3 e to the x dx. This is our answer. Number 8, the integral of y squared dy all over 4 minus 1 half y cubed. This is our answer. So as you can see, there is an ln, okay?